Bé, bon dia a tothom. Benvinguts a la Universitat Oberta de Catalunya. Per nosaltres és un plaer, un honor que estigueu aquí al sistema per parlar d'un tema que crec que és un tema molt rellevant en les èpoques en les que ens movem, principalment perquè crec que les dades obertes i la gestió de les dades obertes i poder demostrar amb dades els resultats de la recerca és l'única via que tenim per legitimar l'activitat acadèmica, per legitimar els resultats de recerca. I en un context com l'actual, on les fake news, ahir en els Premis Nacionals de Recerca es parlava especialment d'aquest tema, és imprescindible que tinguem instruments i que posem i que facilitem l'accés a instruments als investigadors perquè puguin explicar i puguin demostrar que els resultats que obtenen de la seva recerca són resultats reproduïbles, estan ben etiquetats, estan ben organitzats, etc. Per tant, crec que com a sistema és molt important que treballem plegats per poder tenir aquestes eines. Penso també que mancomunar aquest esforç és imprescindible, si no també divergiríem en formats, divergiríem en metodologies, inclús amb nivell d'implantació d'aquestes pràctiques en el sistema. Per tant, agrair també al CSUC que sigui l'òrgan, l'instrument que ens ajuda també a posar-nos d'acord. La UOC, sabeu, és la Universitat Oberta de Catalunya i té el compromís amb el coneixement obert. Per nosaltres, tot el que puguem fer en obert ho farem, la formació, però també els nostres resultats de ciència. I des d'un principi, ja amb el treball de la pastora Martínez, que segurament molts la coneixeu, i de tota la nostra àrea de ciència oberta, hem posat un gran esforç en què tot el que puguem produir sigui coneixement obert. Avui tenim una jornada amb diferents xerrades, amb diferents sessions que el que intenten és posar en comú bones pràctiques, experiències, coneixement, reptes i problemes del nostre sistema. I crec que aquesta jornada l'hem de poder aprofitar i que l'hem d'anar repetint any rere any perquè assolim el proper nivell de desplegament, el proper nivell de, implementació del que busquem, que és un espai que obri el coneixement i que apropi les dades a la societat i a les persones. I un repte que tenim és, com a país, que aquestes dades siguin usades, que siguin trobables, que qui busqui dades les trobi, que no haguem d'anar a altres fonts internacionals que no sabem tampoc on estan hostatjades aquella informació i que puguem tenir-ho nosaltres en el nostre país i sota el nostre control. Acabo donant la benvinguda a Eduard Gil Carbó, que és el director del CSUC i que també us farà unes paraules de benvinguda i d'agraïment en aquest acte. Gràcies.
Hola, bon dia. Se'm sent? Molt bé. Primer de tot, qualsevol acte com aquest ha de començar amb agraïments. Agraïments a la UOC per ser tan bon hoste, per estar dins les instal·lacions i ajudar-nos a organitzar aquesta tercera ja jornada FAIR Data. Agrair també a la gent del comitè organitzador, que hi ha dedicat moltes hores i molt esforç a que les jornades surtin bé. I també agrair a tots vosaltres la presència aquí a les jornades, les terceres ja. Fa goig veure aquesta sala plena de gent. Teníem unes 170 inscripcions, el qual és una demostració que la comunitat creix, la consciència sobre aquest tema cada vegada és més àmplia i ens anem fent grans, diguéssim. Grans en comunitat, no grans en edat. Veig que tots són molt joves. La mitjana és molt jove. Tots cada dia són més joves. Com sabeu, el CSUC, des de l'inici, gràcies a l'empenta de persones com el Lluís, com el Ramon, han estat molt alineats amb el món de la ciència oberta i jo m'atreviria a dir que fins i tot han sigut evangelitzadors. Però el CSUC no és només infraestructures, us podria parlar dels datasets, de les eines de gestió, de la tecnologia que hem posat a disposició de tots vosaltres i de la comunitat. El CSUC, sobretot, són persones, és una comunitat de persones que ha impulsat i segueix impulsant i segueix volent impulsar tot el que té a veure amb la ciència oberta. A vegades jo penso que parlar de ciència oberta és estrany, perquè ciència tancada seria un oxímoron. La ciència sempre ha estat oberta. Per què parlem ara més de ciència oberta? Segurament perquè la podem fer més oberta que mai. Tenim tecnologies que ens faciliten que aquesta ciència arribi més a la societat, arribi més a la ciutadania, es pugui intercanviar de manera més fàcil entre els científics, els investigadors, però la ciència, per natura, és oberta. És més oberta ara perquè tenim més tecnologia per fer-la més oberta. Però al mateix temps fa falta parlar més de ciència oberta que abans perquè els perills que aquesta ciència es tanqui, curiosament, també són més evidents. El que ens fa que sigui més senzill obrir-la també ens contribueix a que sigui més senzill tancar-la. Per tant, comunitats com aquesta, que creixen cada dia, que fan un esforç per convertir tot allò que és el material, el raw data, que diuen els investigadors, essencial per a la recerca, que la ciència es basa en l'evidència, estigui a disposició de les comunitats, no només de la catalana, sinó de l'espanyola, l'europea i de la mundial. La ciència no pot tindre limitacions en aquest sentit, no pot tindre arancels, no hauria d'haver-hi arancels a la ciència, ara que està tan de moda la paraula arancel, i tenir comunitats com la nostra i gent com la del CSUC, que s'implica cada dia i contribueix a evangelitzar i a fer necessari tota aquesta infraestructura perquè les voluntats s'han d'articular amb recursos i amb hores de gent treballant sobre aquest tema, ens assegura que aquestes fires cada vegada tinguin més impacte, més repercussió. Jo ja vaig... És la segona fira a la que vinc. L'any passat, des d'un altre rol a la Pompeu Fabra, el primer any a la UB no hi vaig poder assistir, però és una bona notícia que aquesta comunitat cada vegada creixi i cada vegada tinguem més impacte en el que és la nostra comunitat de referència, que és el món universitari de recerca. Dit això, us agraeixo la vostra presència, espero que d'aquí entregueu bons continguts per emportar-vos a casa. Sabeu que el CSUC està treballant en un nou pla estratègic, el primer pla estratègic del CSUC, i la voluntat és que el tema de la ciència oberta, lògicament, serà un de les línies estratègiques que el CSUC, com no podria ser d'una altra manera, continuarà alimentant i fent créixer, tant en infraestructures tecnològiques com sobretot en comunitat. Moltes gràcies i disfruteu de la fira.
Bon dia a tothom. Jo soc en Fidel Bellmunt i vinc en nom del comitè científic de la Fira per presentar el ponent de la sessió inaugural. Aprofito també, ja que estem d'agraïments, per agrair a la UOC per acollir-nos en aquestes magnífiques instal·lacions i organització. També al CSUC, ja com a membre d'aquesta comunitat a la que feia referència, Eduard, per agrair no només dotar-nos d'infraestructures, de possibilitat de parlar i de compartir sobre tot el que és la ciència oberta, sinó per ser un actor bàsic per articular-nos com a comunitat, que està creixent, que estem aprenent i que estem arribant a fites com les d'avui. Doncs sense més rotllo, ja em dedico a introduir en Mark Wilkinson. Des del comitè, quan vam pensar a veure qui seria interessant que fes aquesta sessió inaugural, vam pensar que seria bo mirar d'aquell moment fundacional, diguéssim, a nivell col·lectiu de la publicació del paper sobre els principis FAIR el 2016. Quins autors d'aquell paper podria ser interessant que ens expliquessin per què van iniciar aquest moviment. Entre ells hi havia la Mercè Crosses, que ja coneixem a bastament, i l'autor principal, el primer, vaja, no el principal, sinó el primer autor, que ja sabem que això dels autors és complicat, d'un paper amb molts autors, és el doctor Mark Wilkinson. El doctor Mark Wilkinson és de Canadà, és doctor en biologia, i per la seva feina d'investigació va anar modelant aspectes, sobretot de les plantes i flors a nivell genètic, i es va trobar amb el problema d'intentar reutilitzar dades que ja existien per fer la seva feina. I a partir d'aquí va començar a intentar modelar sistemes per poder reutilitzar, compartir, etc. i fins a arribar a aquesta necessitat de proposar un sistema, un model per estructurar les dades i fer-les, això que en diem avui en dia FAIR. En arribar a aquest punt va deixar, diguéssim, la biologia i es va ja començar a centrar en aquesta feina de generar models, sistemes per fer aquests principis FAIR possibles, per veure com avaluem els principis FAIR dels datasets, tot això que ja estem fent molts a través de diferents eines, i des de llavors es dedica plenament en aquest àmbit, participant a diverses IOS Task Force, el de mètriques i qualitat de dades, etc. I també va fundar una empresa que es diu FAIR Data Systems, que dona suport i assessorament a entitats per articular les seves dades de manera FAIR. Per tant, sense més temps perdut, dono la paraula al doctor Marc Wilkinson. Marc, many thanks for being here. It's really an honor. And please, the floor is yours.
Just check the microphone. Yes? Okay, good. First of all, thank you very much. This is a real pleasure to speak to an audience about FAIR that is specifically here to learn about FAIR. It's unusual. And so I'm very excited. I'm going to tell you a lot of stories, and I'm going to go very quickly. But luckily, you can download the presentation. This is a FAIR digital object. It has a... Yes, good. Sorry, I understand. So it has a resolvable identifier, permanent GUID, which leads to metadata. It has a license up there. So it is a FAIR digital object, and I would encourage you to put FAIR into your daily lives so that you just start to think about it every time you do something. Okay, so I'm going to tell you stories. Here we go. Buckle up. Data reuse. Does FAIR really help data reuse in practice? I'm going to tell you stories, both positive and negative. To judge this, however, we need to first know what FAIR means. So I'm going to start by talking about how FAIR is intended to help people reuse data, and I can actually show that it works. And I have a little asterisk in a little while, under certain circumstances. But I want to start by talking about some failures. So start with the failures. The problem of measuring fairness. Am I fair, and how can I know? The problem, of course, is rooted in the original publication, where the FAIR guiding principles do not tell you what FAIR actually means. It doesn't tell you how to do it, doesn't tell you what technologies to use, doesn't tell you what to expect. But this paragraph I wrote with something very specific in mind. Machines should be capable of autonomously and appropriately acting during their self-guided exploration of the global data ecosystem. When I wrote that, I was imagining a web of data that could be explored by machines, not by people. And that's critical to measuring fairness. How do we know when we have succeeded? It's when my machine can find the data and use it. That's how we know. So can a machine find and use the data correctly? So almost by definition, FAIR must be measurable because I can write a machine that checks if it can find and reuse data, right? So FAIR assessment is really measuring the degree to which a data record adheres to the principles. I don't know if you know the expression TLDR. It's an English expression, too long, didn't read. So too long, didn't read. Here's the key point. FAIR assessment is a trap, right? Assessment tools behave in very, very different ways by design. And I'm going to show you why they're behaving differently, and then that will help unpack which tool you should be using and when. Okay, the first tool for fully automated testing of FAIR was my own. This came from early pressure in 2017 from journal editors and others who wanted to require fairness, but said we can't require something that we can't measure. So they said we need a way to measure if our authors and our submitters are being fair. I'm going to acknowledge Susanna because I'm all through this. She's going to reappearing because we work on a lot of slide, excuse me, a lot of slide decks together. So there's Susanna, over there. Okay. So the motivation for FAIR testing is that FAIR is a set of principles, not a standard. And the narrative is insufficient. Oh, there it is. The narrative is insufficient to circumscribe the valid mechanisms to achieve it. Nevertheless, when somebody says my data is fair, or my repository enables FAIR, we still need to be able to check if that's true. So this is what my FAIR evaluation tool looks like. It's a very simple interface. I am not an artist, and you'll see from some of these slides, I am not an artist. I'm a tech guy. You put your URL in here and say, please test that for any digital object. And about 22 different tests will be executed, and you will get a score. An example of the tests for principle F3, the principle is metadata explicitly include the identifier of the data it describes. The test says, okay, let's harvest all the metadata that I can find, explore that for any facet that appears to be a reference to the data record, appears to be, and there's actually 18 possibilities that I check, and if I find it, pass. If I don't find it, fail. And so that's how the FAIR tests are executed. That's basically true for all of the FAIR assessment tools. They all work more or less the same way. Okay, so FAIR is not a competition, right? Well, there are now 30 different FAIR assessment tools. And it turns out that if you compare them one to another, you can't. They give different scores for different reasons. They have different numbers of tests. They have different types of tests. They test different digital objects. So you're comparing apples to oranges, and you don't know which one you should be using or which one you can trust, or if any, can be trusted. How different can they be? Let me show you the most extreme example I know. So this top one is my evaluator. So just to note that this is actually the commercial version of my evaluator. So this is the visualization of the FAIR score. 20 out of 22 tests pass. For a record from the Duchenne Parent Project, it's a patient registry for Duchenne children. And then compared to Fuji, which is another popular tool, it scores 2 out of 24. 20 out of 22 from my tool, 2 out of 24 from Fuji. Which one do you trust? Of course, I trust my own, right? So why are they so different? Right? So this is the 10-year anniversary, almost to the week, of this. If you remember this, this took the internet by storm. What color is the dress? I want to talk about why these tools behave differently in this context, because we end up with really bizarre questions like, what is metadata? Right? Which links should I follow to find metadata? To what extent must I follow a standard? If I partially implement a standard, am I following the standard? Or does my tool expect everything to be there? Right? Can I mix? Can I take, for example, DCAT, which is a very popular standard, and mix it with schema, which is another very popular standard, and cover both, possibly redundantly, or maybe just some from here and some from there? What is acceptable? We don't know. Right? And so what color is the dress? Every tool maker is interpreting and answering these questions differently. And there's an enormous disagreement between the tools for other reasons. Right? So if you look at the FAIR Evaluator, I have only 2 tests in the R's, because I think that R's are community specific. You can't generalize R tests. Whereas Fuji, the vast majority of their tests, 10 of their tests are in the R's. So we can't even really agree on what the FAIR principles mean. Now now that we've done some more investigation, I'll talk about in a few seconds, I better understand what's happening here, is that Fuji is intended for a very specific type of digital object. So it has additional expectations that my tool didn't have, but I didn't know that when I first did this. It's only from really deep investigation that we've learned what's going on. Of course, EOSC was concerned. They're trying to build an internet of FAIR data and services that they can't measure. So they asked for an investigation of these discrepancies, and they founded the first FAIR Metrics and Data Quality Task Force. This is in 2021, co-chaired by me and Chris Schubert. And I'm going to talk about a few of the outputs, not all of them. In particular, I want to talk about this one. So we were tasked with trying to harmonize the different assessment tools. So we got the tool builders together in a series of hackathons over 2 years. We had probably 5, I think, total meetings to try and harmonize the tools. 6, there we go, 6 workshops. We discussed the basis for the differences, and we identified that metadata discovery and harvesting was approached differently. The different tools had different expectations and different levels of tolerance for deviation from expectations. Right? Now, I'm going to get a little bit technical. For some of you, this will be second nature, but maybe not everybody. I'm going to walk you through a harvesting event so that you see where the ambiguities come from. So how does metadata harvesting become a source of discord? I'm going to use Zenodo as my example. So this is a typical harvesting workflow for Zenodo. You start with your DOI, and then you call that DOI over the web using a particular accept header. You're saying, I want metadata specifically. What DataCite does is they then intercept that, and they send you back a block of metadata that they know about. You then go back to your DOI, and you pass it again, and this time you say, I will take whatever you want to give me. DataCite then redirects you to, eventually, Zenodo, in this case, Zenodo. Behind Zenodo, in that what's called a landing page, there's additional metadata. Right? So that metadata is partially overlapping with the metadata at the top of the screen. And one of the technologies they use is called typed links. And inside of those typed links, we have, for example, a relationship which points to a trigrams.csv file. Great, so it's actually pointing into the data. However, this relationship, alternate, is supposed to be a representation of the entire deposit. And that CSV file is not a representation of the entire deposit. So now this is back 4 or 5 years. I looked last night, and they have fixed it. So they now have the alternate and the correct relation, which is item. So Zenodo is now behaving correctly, yay, but I've been watching them because I knew that they were going to be rolling out this correction soon. So this has been patched, everything's good. But you can see the general problem. Right? So metadata harvesting agents have to guess. Zenodo doesn't advertise that that is the correct call to get their metadata. You have to know that. There's different interpretations of the specifications, like alternate versus item. Ambiguous interpretations of what is a landing page. Right? So some some DOIs resolve directly to the data. This one resolves to a landing page. So what does the DOI represent? Does it represent the data, or does it represent the landing page? Right? There's no consistent way to discover the data, and I put a couple of stars beside that because I'm going to come back. There's no consistent way. So Zenodo has this item link, but other repositories have other kinds of links. Some of them have no links. There's no consistent way to discover the provider source, the person who created the data, the provider source metadata, which is the most important stuff. No way to find it. And this is one example with a widely accepted identifier, DOIs, and a very mature repository, Zenodo. Right? So that's how you end up here. Right? It's chaos. In the real world, it's chaos. So how do you resolve fundamental disagreement among experts? Ignore it. we tried. Right? So I'm going to now talk about the second output from the task force, which is fair signposting. I've actually got water here, thanks. There's nowhere to put water on this table. So we have 30 assessment frameworks. There's a lot of disagreement, and there's no incentive to harmonize. Everybody thinks they're right. Right? And they're experts, and they are. Right? So the solution is to move the goalposts. Right? Instead of harmonizing the tools, let's get everyone together and say, is there an approach that we all agree is fair and then let's make sure all of our tools score that one exactly the same way. And so that's what we did. And we chose a technology called signposting, and actually a subset of that called FAIR signposting. It uses typed links, but it uses them in a very, very precise way, in a very simple way. There's 3 links required for FAIR signposting. By the way, just to acknowledge Herbert van der Sompel, who's at DANS, who authored signposting and authored also the FAIR subset. So there's 3 relations. One is cite as, which says this is the canonical identifier for the thing that you have in your hand right now. Described by is a one-to-many relationship. These are all of the sources of metadata that I happen to know. And finally, item, which is a pointer to every data file. Very fair, right? There's no ambiguity anymore about what everything does. So what that looks like now, that workflow, is I arrive at this page somehow, right? Through DOI resolution, through a bookmark, through somebody emailing me a link, through whatever. I arrive here. When I arrive here, I am given the signposting. I have a link to the canonical identifier. I have a link directly through DataCite. No ambiguity. I don't have to do content negotiation for the techies. Straight through DataCite to the metadata and any other metadata that I know, and then links to the individual data items. And critically, I can use the described by to point inwards to the metadata provided by the person who generated the data. Right? That's the critical stuff. So we have and by the way, RO crates, if anyone's using it, yay. If you're not using it, please go to their website and look. RO crate solves a lot of problems. So I'm going to come back to it again later. But I'm a big fan of this approach. Okay, so this is work in progress. Uptake of signposting is growing. So Dataverse, excuse me, Dataverse is complete. It has a complete implementation. Zenodo has a complete implementation. RO Crates does. The FAIR Data Point going to come out this week with a complete implementation. It is on the to-do list for these other repositories in the Gray consortium. So we're getting there, but I understand that a lot of you are using Dataverse, so yay. Again, TLDR, if you use a signposting compliant repository, you're going to score very highly on pretty much all of the tools. Okay, I'm going to return to this list now and focus on that. There's no consistent way to discover the data. There's no consistent way to discover provider source metadata historically. With signposting, there is, but not everyone has implemented it. So the question is, what are these tools testing? Open question. What are they testing? Sorry? They're not testing your data. They're testing the repository. The one thing that you as a data provider have zero control over is what they're testing. And that is really unfair. Right? When we ask people to provide fair data, and we have absolutely no way that they can ever improve their score, so we have to solve that. And so now we get to the fear, right? The fear part. Is FAIR fulfilling its objectives? Are we really supporting the automated discovery and appropriate reuse of data? What incentive do you as a provider have to make your data fair if there's really no way to find it? So Task Force Phase 2, this is me and Eli Papadopoulou in Athena Research Center. We are doing a second task force where we ask that specific question: to what degree, if at all, is FAIR making a difference to data reuse? Can we measure any difference? The work is ongoing. I don't know what the answer is going to be. I'm not optimistic. So then I want to talk about another project I'm involved in, which is tackling similar problems, but I think in a very, very pragmatic way. So I want to acknowledge Natalia from OpenAir right now, who's the CEO of OpenAir and head of this initiative. So this is delivering a commons of plan, track, and assess tools for open research, open science. Plan track means we're going to have machine actionable data management plans, and we're going to embed FAIR best practices into the authoring tools. So if you're using Data Stewardship Wizard, this will be embedded inside the Data Stewardship Wizard, and it will tell you what you should do to be fair. Right? And you'll be able to click a button and assess your fairness throughout the research process. Right? So as you go through the project, it will look at your plan and go and check. And if if you're halfway through, it'll recognize that and say, okay, these things have not been done yet, but I can check these. And so you'll have a constant feedback about your success in executing your plan, as well as advice on how to do it. And so by doing this, we want to try to make research data fair at birth. So that you're doing it from the outset without putting fair on top of it later. You're birthing it as fair data. So this is coming from the FAIR Metrics and Assessment Work Package. So from the FAIR Metrics side, it's me and Daniel at UPM. And again, Susanna from the FAIR Metrics Governance side. We want to operationalize the decisions of the task forces, harmonize fair assessment through standards and APIs, design and publish metrics and tests, now this is important, for a range of digital objects beyond data, as well as community and domain-specific metrics and expectations. Right? Because different fields have different expectations for FAIR, different standards. And we want to professionalize the ecosystem through good governance. We need everyone to trust. When an assessment is made of your resource, you have to trust that it's being fair, lowercase fair. So we want to professionalize it through good governance, transparent governance. Let's look at what the tools do. Now we're going back to these differences between the tools. We did a really deep dive into how these different tools behave. And it turns out that by design, they're not even trying to behave the same way. So we broke it down into the different facets or the different components of fair assessment. So we have the dimension, which would be, for example, a FAIR principle. We have metrics, which are things that are measurable. We have benchmarks, which are expectations about those metrics. What is good, what is bad, what is acceptable, what is not acceptable. And then we have a software layer where the metrics are actually coded, right, where the test actually happens, scoring algorithms which take the output from the tests and compare it to the benchmark and give you the final interpretation. And then, of course, we have the data layer down here, which gives you all of the actual data. And I want to focus right down there on that word. So this is where we really want to be. If I say you scored 10, what does that mean, right? I want to know you need to fix the content type header on the message coming back from this URL. Thank you. You docked 2 points for that, but you didn't tell me. So what we want to do is migrate from assessment to assistance, from judgment to guidance. So we're currently studying the kinds of guidance that everyone needs to make better decisions, how to integrate that into fair assessment tools. And we'd like to really just replace these crude numerical values. They don't mean anything to anybody. They're not comparable between tools. They're not comparable at all. They're not interpretable, right? I'll give you a quick preview of the kinds of things that we're looking at. So this is from Wim again at Dans, the different kinds of guidance that exist. So we're again doing a very deep dive into what kinds of things can we provide to you to improve your fairness. Okay, so things will get better, right? Okay, now I want to talk about some success. I've talked about all the failures, and I don't want to depress you, although the theme of the conference is fear. So I want to end with success stories, right? So I want to talk about 2 places. Now, this is only my own examples. I know that other people are working in the same field. I'm just going to talk about mine because I have a lot of control over mine. So in the area of rare diseases and seed banking, so an example of a successful initiative is the European Joint Program on Rare Disease. If I say EJPRD, that's what I'm talking about. So the EJPRD numerically is 1,800 participants, 35 countries, 101 million euro budget, 91 beneficiaries, and I was on the tech pillar for that project, and our task was to make everything fair. Now, in parallel, there were other rare disease registries who were not in EJPRD, and they came to my company. So this is full disclosure. A lot of what I'm going to show you now is actually done by my company, not by me as an academic, but it was done in parallel with the EJP, right? So that's my company there, Fair Data Systems. We worked in parallel, we shared goals, we exchanged software because everything was open source. But I'm only going to tell you one story, and that is the Duchenne Parent Project. So this is a registry of parents who have Duchenne children. And it collects from an app information on a day-by-day basis about the symptoms the child is exhibiting, their what drugs they're taking, what complications they're having, and so on. So it's constantly getting fed information. This is a FAIR data point, which captures the metadata describing the entire registry of patients. And so what you'll see is that I have the basic themes, the Duchenne muscular dystrophy and Becker muscular dystrophy as the orphanet codes. And then I have, for example, phenotypes that appear inside of that registry, like bone fracture. So all of that metadata has to come from somewhere. I cut off the title. Where do those all come from? So they come from what are called PROs, patient-reported outcomes. They have an app that asks questions, right? Such as questions about bone health, orthopedics, gastrointestinal, cardiac. Inside of each section, there's questions such as, are you experiencing a bloated feeling? And the patient answers are recorded day by day over all of the patients. Now that's not easy for a machine to understand, right? Bloating is not machine understandable. So my company went into their main question database and we created a controlled vocabulary from all of their questions, and we cross-linked that into all of the phenotypic vocabularies to make it all fair. Right? So here you'll see we have a formal hierarchy of the different sections of their questionnaire, and down here we have more specific questions about arm support, brand of arm support, and so on. Gastrointestinal bloated feeling is now given an identifier, DPP00075. That is the question identifier. Right? So now we have a resolvable, unambiguous identifier for every question in their survey. If you resolve that, you'll find that it has cross-links out to other vocabularies. So in this case, the Human Phenotype Ontology, which is abdominal distension, and the National Cancer Institute Thesaurus, which has the concept of gastrointestinal problems. So we're cross-linking their question out to controlled vocabulary so that machines can understand what the question is about. And those end up going into this top page to aid discovery, right? I'm looking for a database that has Duchenne patients who are experiencing bloating. Are there any? There's one. Whew, that's a lot of work just for discovery. Right? It's a lot of work for discovery. So can we do something more? Well, let's go down one step. So interoperability is going to get harder work, enabling federated analysis with what we call the clinical and registry entry semantic model. So we built, there was no existing data model for PROs. And so we had to invent one. There are a lot of examples in clinical research where there are existing models. In this case, there was not. So we built on top of the semantic science integrated ontology, which is authored by Michel de Montier, who is now in, he's another Canadian, but he's now in Maastricht. And then my PhD student, Pablo, who's now not a student anymore, still a technician with me. So Pablo created this model, which is a generic model for capturing clinical observations in the form of questionnaires, but in fact, more generally, clinical observations. So we can capture, for example, corporal measurements, measurements of body parts, imaging, laboratory measurements, chemical measurements, questionnaires, and so on. So you don't need to think about the details of this. I'm just going to zoom in on this for a moment to show you three pieces. Here is a node that requires the question ID. Here is a node that requires the answer to the question. And here is a node that requires a cross-reference. So now I have all that information. I have the ID of the question. I have the cross-references that can go in here. And I have the answer from the patient, of course. Yes. So now when I ask that question, I can immediately move it into a fair representation, which can now be shared and understood by machines. A lot of work. Okay, I can do it, but can they? The problem is that the people who are capturing this data are capturing it in some format, database, spreadsheet, CSV. We want to become fair with a minimum of disruption, and generally even through my company, I'm not allowed to see or touch the database in most cases. In the Duchenne case, I was, but in general, I'm not allowed to see it, touch it. I don't have the authority to. So we need to somehow give the power of mapping to the user, to the collector. So we're using two technologies, RML and YARML. Basically, this is what it looks like. The CSV is generated by the participants, and it is quite literally that. They have a column called property, diagnosis, body measurement. They have a column which is the observation that they made, the value, and then some metadata about the date. They generate that, which is something they do all the time anyway. They can very easily generate CSV. We click a button and we push it into this model using the YARML technology. So in the case of diagnosis, here are the nodes that need to be filled in orange, the nodes that we have already filled in green, and we give them the template. So the template is, we need you to give us some identifier, we need you to give us some attribute ID, so in this case, the human phenotype ontology or the orphanet disease ontology. There's other things that are optional, and including the comments. And this is what happens. So they select the data types, corporal measurement, laboratory measurement, clinical intervention, imaging. They select the data types that they're interested in. They take a template from the GitHub repository, the CSV template. They do their extraction following that template, and then that's it. They end up with the CSV file. They push a button, and all of the rest of this happens automatically. So that's executed by them up to the point of getting a CSV file. All of this is called FAIR in a box. The transformation and the publication and the pushing of the metadata up into the public layer is all automated. So in principle, I never have to see or touch the data. They click the button themselves, everything else happens. And this is the FAIR data point that I've shown you before. So it's both public and private parts with the protected FAIR data behind a firewall. Okay, does this work in practice? Sounds a little bit complicated. So we did a test. So we contracted to work with 5 independent registries in 3 countries. Every site was responsible for generating their own CSV that followed the template. Everybody shared the YARML models that are used as the transformation, and then they do the transformation by themselves. The data owner does the transformation. Does it work? Well, the way to test that, because again, we can't touch the data, is that we had to do some queries. Now, queries over clinical data are tricky, right? Because it's private data. So we first of all had to solve the problem of doing queries over sensitive data. So we invented privacy-preserving federated query technology and governance. Right? So this is this is the problem, right? We've done all these transformations. We have to prove that the data is, the theme of the conference, reusable. Then we prove reusability. So the technology that we're using is called Shallot, which is an adaptation of a previous technology called garlic. And it's a little bit lighter than garlic. Right? It's designed, I deleted all of the code that made it not safe to run in sensitive environments. And so now it can do very, very little, but it does it really well. Right. So for the governance side, we have a review panel of clinical experts, FAIR experts, privacy experts, patient representatives to say, do they feel comfortable with their data being used in this way, regardless of consent? We go back to them and say, this is the question we're going to ask. Are you okay with that? So they decide which queries are going to be allowed, and we have a governance over, is that query accurate? And the clinician says, is that query relevant? Is this something you should ever ask, or is it an irrelevant question, or worse, a question that could lead to questionable conclusions, right? Things that judge ethnicity, for example, and right, you can get into dangerous parts. So the clinicians say this is a relevant or irrelevant question. The FAIR data experts say this is a correctly formatted query. The patient representatives say, I feel comfortable with this question being asked. Every site is allowed to choose the queries that they publish, and every interface is open, 100% open, because this has already happened. The queries are privacy preserving, the patients agree, the interface is completely open, no passwords, no nothing. Now, this is the kind of question we can ask. Which registries contain records of proximal spinal muscular atrophy? So if you look here, here is the address of each of my Shallot queries for that particular question. And then what comes back, I ask all of them and they come back and I graph them because they send me the data in exactly the same format. So here's a graph where I queried over 5 resources. They all gave me the same, they all gave me an answer that I was able to quickly integrate. Okay, yay. Now that's a good proof of concept, but it's not really what we wanted. We really want to do research with this data. So I went to the EuroNMD Key Performance Indicator publication, which has a series of expectations of registries, right, and expectations of the healthcare system related to treatment of Duchenne patients. And I picked one of their KPIs, which is the time from onset of symptoms until the diagnosis is made. In rare disease, this can be very long, years, right? Because a lot of the doctors have never seen those symptoms before, so they don't know what they are. So from the symptom onset to diagnosis is a really critical measure for the accuracy and efficiency of the healthcare system for rare disease. And so I thought, okay, let's pick that one and let's solve that. So I created a Shallot query for KPI time to diagnosis. I ran it over all of the registries, and here's just 2 of them. So the Duchenne that I run here. So you'll see that I'm gathering the time to diagnosis based on the year of the diagnosis. Over here, they're using mock data because they didn't have a registry with consent at the time. But we're able to ask the question, right? The question, by the way, is not trivial. That's the query. That query is being executed over all participants. Exactly the same query. I'm not touching it. The query, by the way, is public. It's in a GitHub, an open GitHub, so everyone can see it. Because we need trust. So the query is non-trivial, but it's still being successfully executed over all participants, right? So, success, right? That's a relevant research question. Not yet. We're not there yet. See, we need to be more fair, right? I still have to tell my system the address of all of these Shallot endpoints. I have to know the address of all those Shallot endpoints. I shouldn't, right? In a fair world, a machine would find that by itself. So my agent is pretty dumb. So I'm going to have to solve it by following the FAIR principles even more rigorously and improve the metadata. So F1, I2, and R1 all require that you do more work. More work, more work, more work, always. So I went to the key performance indicators and I ontologized them. Every one of them now has a definition and a URI, a resolvable URI, so we know we're talking about the same KPI over all repositories. Then I go to the Duchesne Parent Project metadata, and I enhance the metadata record for all of the different services. So the first one there is the KPI diagnosis delay, but I have various other services that I offer. Every one of those services now is associated with an ontology term saying this is the ontological type of that service. And I do that for all of them. So now, instead of saying execute the service at this address, execute the service at this address, execute the service, now I just say to my agent, I say, find and execute all KPI 0007 specifically for Duchesne. And my machine is able to go and query the metadata and say, that one, that one, that one, go. Right? So now we have success. That is fair. It is proving data reuse, interoperability, right? Smart agent. Okay, now let's go back to the pain and the fear. The full stack of technologies required to make that work was OWL RDF. We're all, and linked data, we're all comfortable with that. But then we have the metadata and the data layers, which are specific, and in some cases, like CARE-SM, we had to invent it, including some ontologies we had to invent also. Right. So, caveat emptor, FAIR alone is not sufficient to achieve interoperability or reusability. You have to share models. And the thing is that we already knew that. Right? It's almost trivial. We already knew that if everybody had the same model, we could do data integration. We already knew that. Discovery is really what's happening here that's exciting. Right? The discovery of which endpoints are capable of answering this question sensibly. We have a publication which makes me laugh because I say it, the FAIR is a Rosetta Stone between clinical models. The word emergent there is carrying a lot of water. We say in English, it's carrying a lot of water. The expression I use is, we put lipstick on a pig, right? So fairness between two non-coordinating registries results in almost no interoperability, almost nothing. And we were able to prove that in our paper. So I want to talk now about our latest initiative, which is pushing this a little bit farther because I have a bit more control over this one. This is a project from the Gobierno, which applies similar problems to the area of seed banking. So it's called FAIR GG. And the idea was that we're going to expand EJP rare disease to germplasm banking. This is my collaborator, Santiago, who's the head of the Banco de Germoplasma Vegetal at UPM. Just to give some background, the germplasm bank at UPM is really important. So there's 1,027 taxa, but importantly, it currently preserves 24% of the threatened flora species in Spain. So it's an important collection. The big picture is this. So this, I'll give you the TLDR at the beginning here. The big picture is that we have FAIR data points for metadata, we have shared models for data, and then we have a way of bringing third-party data sets in, so data from people who are not participating in the project. All of these things can communicate. Importantly, the different germplasm banks are able to communicate not only with the government or whoever they want, but they can communicate with each other to coordinate, for example, collection expeditions to go out and find new seeds. Do you have this species in your bank? I don't have it. Right. They can communicate with each other automatically. They can communicate at the metadata layer or at the data layer. And we have over here a way to bring other data sets into what I call the platform up there. Okay, so the status, I'll go quickly now, because this is very much the same thing. We have FAIR data points which are customized to the germplasm, automatic installer available. Everything can be collected in Excel. And we're hosting at UPM, we're hosting these resources for any network partner, just to bring people in as quickly as possible. We've created the standard data model. This is the work of my PhD student, Alberto. So we have, very similar to the clinical case, we have shared models for germplasm for administrative data and for location information. Interestingly, germplasm has very similar problems to clinical. The most sensitive data about germplasm is its geographic location. If you give that away, people will immediately rush there for an endangered species and take it all. Right? So we have similar sensitivity in our data to clinical, which in that case it's identity. In this case, it's geographic location. So we have very, very similar kinds of problems and protections around the data. We have an index of all of the partners. We can check which ones are active, which ones are inactive, which ones have disappeared. And then we have the FAIR virtual platform, which is a portal where you can start your exploration of everything. We're driving traffic out. We don't collect data. We drive questions outwards to the individual participants. So they become critical. We don't take their data. So they trust us because we don't take their data. And we have one-click launching of question-specific analytics, like you saw earlier. Importantly, for example, from the ministerial, we can take many different kinds of government data, bring it into the platform, integrate it with the germplasm. Again, we maintain, this is now going to be a focus of the last couple of minutes. We maintain the provenance. And this was by design from the outset of the project. I'm going to say that many times before the end. From the outset, we realized that a federated system is going to have to capture provenance in a way that is not normal. Right? When you go and you collect a data set, that's one thing. When your agent is going to 5 or 10 different locations, taking pieces of data from each one, that's an entirely different provenance problem. And you are responsible for that. If you don't do it, the people giving you the data don't trust you. So we are able to federate queries. So one of the ways that we federate is using a language called Sparkle, but we have many other different ways to do federated search. What can we do with that? For example, conservation strategies. So in Spain, here are the observations. The yellow dots are observations of a particular species. The red dots are places that have been sampled. So do we have a good geographic representation in the banks from across Spain? We can make that judgment, right? What you really want to do is this. You want to say different species in different environments will have different pushes on their genomes. Do we have a representation of all of the different environmental genomes? So dry soil, wet soil, salty soil, windy, hot, cold, right? Because breeders want to be able to take those seeds to make their special breeding plans. So we want to be able to do that. We want to bring in IMET, we want to bring in geological information, geographic information, and so on. And we can, using this platform. So the next steps, if we get the Plan Nacional, which we should hear in the next couple of days, is to actually go and start building these queries. I'm going to show you a demonstration of federated query, data reuse, using the FAIR virtual platform. What germplasms are held in Spain over all of the participating germplasm banks that are in the endangerment categories of vulnerable, endangered, or critically endangered? What's the name of the species and which germplasm bank holds it? Complicated question, could not be asked. Could not be asked until this, right? The virtual platform knows what banks, because they're all ontologized, it knows which banks are capable of responding. So I'm going to pick the banks I want responses from. I'm going to say, click, go. Here, I'm getting the responses from the different banks. I'm keeping the provenance. I know which response came from which bank. I haven't yet integrated the outputs. To look a little bit closely, it's all perfectly anonymous in the plant sense, There's no information I couldn't publish. There is, in fact, a filter for certain species nobody is allowed to know exist in banks because they're just that sensitive. And so we filter those out, right? And then at the top of the page, you have that, a link. This link knows everything that you just did and the context in which you did it. And it will link out to an analytics environment that is already configured for that question. So I click. I'm connected to a secret stash, which is protected, that it then pulls the data into my analytics environment, and there's the analytics. The analytics environment is pre-coded. This happens automatically, so the person who's doing the conservation strategy doesn't have to know R, they don't have to know Python. These things are pre-coded. The most obvious things are pre-coded. And again, we're keeping the provenance information. So we know who gave us what information. Okay, TLDR, almost my last slide. The biggest thing to fear about pursuing data reusability is that it's really hard. It is really hard, and it does not emerge from a pursuit of fairness. You have to do more. And then again, I'm going to say from the outset, if you're going to build federated integration data reusable systems, be ready to capture provenance, because you don't want to lose the trust of the participants. Okay, take-home messages. FAIR is necessary but not sufficient. So I've shown you repeated examples of reusability. FAIR is metadata first. Almost all of the things you saw were enabled by metadata. Fairness is measurable, but we need global governance before anyone can trust assessments. And at the moment, we're almost never able to measure the fairness of data. There are technologies and strategies that allow FAIR experts to assist domain experts to create FAIR metadata themselves, even without direct interactions. And within defined communities, you can get a very high degree of reusability if you start to share models, which we already knew. But we just showed it. Share the semantics, share the models. Okay. So, I don't know if I went over time, but acknowledgements. My lab, I've been acknowledging my collaborators in situ through the talk. Again, you can go to the, I know I went quickly, you can download it, do whatever you want with this presentation. It's always open. And then, of course, have to thank the funders, the numerous organizations involved. And I'd love to take your questions. Thank you again for the invitation. It's been a pleasure. Stunned into silence. Nope, not yet.
Oh, yes. So thank you, Mark, for your interesting presentation. For sure, we will download the presentation because there are a lot of links there and examples we need to check each one of them. I think there's a mandatory question here, especially when we talk about the assessment of the fairness of our data sets. How do you think artificial intelligence tools can help us on the assessment of the fairness of our data set? How do the artificial intelligence tools we have right now can help us on the assessment of the fairness data sets we have?
I mean, so long as you are in control of the environment, you can deploy the assessment tools inside of firewalls and so on. I'm not sure if I didn't quite catch the whole question, but the assessment tools will assess whatever you give them. What's important is that the different tools are intended to assess different things. So I'll give it a specific example. So there's a tool called FOOPS, F-O-O-P-S exclamation mark. It's part of the name, the exclamation mark. FOOPS. which is a play on words on oops. So I've made a mistake. And what it does is it tests ontologies only. And ontologies are an unusual case because the metadata for an ontology is embedded inside of the ontology itself. So unlike a data deposit in Zenodo, where you have a layer of metadata and then a layer of data, the ontology tool can only test ontologies. So selecting the right tool will allow you to better assess. I don't think I'm answering your question. Maybe try me again.
Just a direct question. Can I ask ChatGPT to look into my data set and see how do you see that? Is that fair? Yes.
So I have some thoughts about the use of AI. I'll probably go broader than your question. At the EOSC Winter School just a few months ago, we were talking about where does AI fit in the FAIR world in general, not just assessment, just in general. And one of the things that large language models do extremely well is detect context, which is why we use ontologies. And so to some degree, an LLM is able to detect context without us necessarily applying an ontology term to say what we meant, what we intended. That tends to get inferred reasonably accurately by an LLM. So the question went in both directions. Can we employ LLMs when we teach them the ontologies that we have? Can we employ them to automatically annotate? Probably yes. The other thing that I've been playing with is automatic data transformations from one clinical record format to another clinical record format. Those are not bad either. It's not perfectly accurate, but it's not bad. So in that direction, going from native formats into FAIR formats seems to be okay. The question is the other way around. Do we need ontologies at all in that case? Why don't we just do integration using LLMs? The problem in that case is, is that, for example, clinical data, you can't feed to an LLM externally. You'd have to bring it inside. And some of them just won't fit inside because you can't send the patient data out of the repository. So in those cases, you'd need annotation systems or something. So it doesn't entirely solve the problem, but I mean it does push the point that we may be getting to a point where ontologies are getting increasingly superfluous. Right? There has been a lot of investment in ontologies, and they've helped us a great deal. But if the machine can do the inference, well, we talked last night about this a bit. When you adopt an ontology, you are buying in to the belief system of the person who wrote it. So when they say this is the definition of a serine threonine kinase, you have to accept that. Right? Whether you believe it or not, you have to accept it if you're going to use that term because that's the agreement. In reality, you'll find that domain experts disagree about these concepts. And so the ontology is a little bit constraining, right? Because they are forced to accept a term that they don't necessarily believe the definition, or they don't think that this term should be applied to this gene, for example, because they disagree. The future LLMs, I think, are going to become much more personalized. I'm going to give Grok access to my publication history, going to read all of my papers. It's going to know all about me, my Facebook history. I don't use Facebook, but in principle, right? It's going to know all about me. And it's going to be able to start interpreting the world the way I would, through my lens, where ontologies tend to force a lens on everybody to get the data integration and the data harmonization that we needed. I would imagine in the future that's going to change, that things are going to become personalized to the point where you get to see other people's data through your own eyes. And then ontologies start to become less useful. I hope that's the answer to your question.
Hello, can you hear me? Yeah, here.
Hello. You have to speak loudly, even with the microphone.
Okay.
Thank you.
Is it better now?
Yes.
Okay. So my question is going to be very broad, and actually I'm just taking advantage of all your knowledge with this question. So in my institution, we're working towards having all our data more fair or increase the fairness of our data institutionally. So recently we just have launched the Dataverse, and we also are working with data stewardship wizard and all these things. So actually now I want to start with ArrowCrate, and you said ArrowCrate, yay. So I was thinking, is there any recommendation, advice, suggestion on how to increase fairness on the institutional level with all the data that we are producing using ArrowCrate? And if it's in the context of Dataverse, that would be amazing, because I know there's some importers and this kind of thing. So I don't know if.
So I don't know the specific answer in every case. So I know in the case of Zenodo, I'm not going to say I know. I believe that in the case of Zenodo, they do not yet provide a specific facet in their when you submit that will point to your specific metadata record. However, in ArrowCrate, the top level metadata record has a predictable file name, which is beautiful because that gets around the problem, because the Zenodo record has these item links and every item points to a deposited file. You can scan through those items until you find that file name, and then you have the top level metadata, and then you're off. You can explore the entire data record from that point. I believe that Dataverse, the latest versions of Dataverse have something like that. I don't know. Again, my conversation with the developers says that they were going to make that a facet. I don't know if they have yet. But you can do similar kinds of exploration. But ArrowCrate is another solution to the provenance problem, right? So when I do a federated query, I can take the query results and package them up as an ArrowCrate and send that back instead of the raw query results. And then I have the full provenance record and the query results in one package. And so I see ArrowCrates solving a lot of problems. And especially that one with provenance, where if you don't do it that way, you have to invent something. And we don't want to invent something. So that's why I'm very pro ArrowCrates. And our ArrowCrates themselves are adopting internally the signposting spec. So you get both for free. Is that an answer?
Yeah.
Okay.
Thank you.